Howdy, AP PreCal. It's Miss Kosh. We are continuing the 2-1 and 2-2 notes. We have done arithmetic sequences, and now we're talking about geometric sequences. And so on this one, I'm following a very similar format for my notes. I hope you appreciate that or like it anyway. So same idea. So notice on this, when I go 3, 6, 12, 24, you'll notice that each time I am multiplying by 2. So I have, if I multiply by 2 again, I get 48. If I multiply that by 2, I get 96. And so now we want to figure out the nth term. And then this time I didn't ask you for the 100th term because it gets ridiculously large and I didn't want to do that. So we're going to ask for the 10th term. So here's what we want to think about on this. Notice, okay, if I have, how do I want to write this? Okay, we're going to make a little table. I have n, I have a sub n, the first term, the second term, the third term, fourth term. Okay. My first term was 3, my second term was 6, then it was 12, then it was 24. Notice on this one, this is 3 times 2. This is 3 times 2 squared, because there was another 2. This is 3 times, well, 2 squared times another 2, which gives me 2 cubed. So if we back this one up, notice this is 2 to the first. This, 3, would you agree, is equal to 3 times 2 to the 0 power, because any number to the 0 power is equal to 1. And so this number here, we can relate this number to the exponent by taking the n value and subtracting 1 to get the exponent. So 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3. So if we're jumping out to the nth term, if this is n, then we're going to have 3 times 2 to the n minus 1. Hope you couldn't see what I was doing. That's what I was doing. Okay, so let's write that down over here. The nth term is 3 times 2 to the, that is so wrong. 3 times 2 to the n minus 1. And we do, once again, I'm not grading your handwriting, but I'm grading your handwriting. That matters where we write those. Okay, so now I'm going to look at the 10th term would be 3 times 2 to the, well, 10 minus 1 is 9. And so my 10th term is 1,536. Super. Okay, notice on this one I have 125, 25, 5. I recognize those as powers of 5. And I also recognize I'm dividing by 5, but I'm also multiplying by 1/5. And so a fifth of that is 1, a fifth of that is 1/5. So what we did here is we had our initial value was 125, but we multiplied it by 1/5 to the n minus 1 time. So let me show you. So if one way to think about it, 125, hit enter, I can multiply by 1/5. And here come those values that we were looking at. Another way to think about it is we can come to that table. Oh, here's table. Delete. We can say 125 times 1/5 raised to the n minus 1. And there are the values that we care about. Okay. And so, what did we really care about? We wanted the 10th term. I'm going to override that and tell it 10. Oh, goodness. Okay, notice it gave me this fraction over here, which is better. So this is weird notation, but what they mean is this is 1 over 15,625. All right. Another way to think about it is this 125 times 1/5 to the 9th, because 10 minus 1 is 9. This is 5 to the 3rd times 1 over 5 to the 9th, which would end up giving me 1 over 5 to the 6th. And if you notice over here, well, if 5 to the 6th is not that number, then I've done something crazy wrong. Oh, good. Those match. Super. Oh, can you see it? Hopefully. I'm sorry. Hopefully you can see it. Okay. This next one, when I look at this, this next one, I see this. Let's try this negative 54 divided by 81. Oh, and make it a fraction, a negative 2/3. Okay, so let's see. Let's see if this follows that recursive pattern. If I take 81 and multiply it by a negative 2/3, do I generate the numbers that I expected in my list? Yes, I do. And after negative 24, I get a positive 16. And then I get a negative 32 over 3. Okay, and so this is our common ratio, is this negative, so we had our initial amount times a negative 2/3 to the n minus 1 power. So if I take 81, well, okay, let's see. Let's come back to the table. It's kind of nice to work with that. Delete 81 times negative 2/3 raised to the n minus 1, x minus 1. And I can go look at my tape. Is it going to get that right? It did get it right. That notation, did that bother anybody else? It's looking like just the x minus 1 is, the x minus 1 is just affecting the negative 2, and that makes me start twitching because it's not what it's doing. It's affecting the negative, the 2, and the 3. But that formatting, I did it in parentheses on purpose, but they got rid of that. Okay, but here we go. It gave us the terms that we wanted, and we want the 10th term. And so the 10th term, we can write it as a fraction, negative 512 over 243. Another way to think about this is this was 81 times negative 2/3 to the 9th. Well, 81 is 3 to the, well, it's 3, then 9, then 27, then 81. This is 3 cubed. I lied. That's 3 to the 4th. Oh my goodness, you guys. Negative 2 over 3 to the 9th. So there were 9 3s on the bottom and 4 3s in the top. So this ends up becoming a negative 2 to the 9th over 3 to the 5th power. And let's see. When I come back here, let's see if I can do it by hand like that. I should be able to. Negative 2 raised to the 9th. Sure, that was 512 that we expected. And then 3 to the 5th. Sure enough. Oh, good. Okay. I'm sorry. I think I keep moving the paper out of the way where you can't see it, so my apologies. We can also use a recursive or an explicit formula for geometric. So once again, it tells us what to do. I lied. Oh, my goodness. It tells us where to start and what to do. It says start at 6. And then take the previous term and multiply it by 2 to get the nth term. If this is not clear to you, go back and watch my arithmetics video where I talk about this a little bit better. Multiply by 2, multiply by 2, multiply by 2. There's the first 4 terms. Okay, on this one, now they're saying, well, we have 3, plug in 1, we raise it to the 0 power. That means 7 is our first term. Then when I plug in 2, 2 minus 1 is 1. So that's 3 to the first is just 3 times 7. Is 21. Notice I'm multiplying by 3 each time. That's 63. Multiply by 3 again. 189. Okay, there's the first 4 terms of that. This one, where to begin, what to do, take half of it. Oh, that was cool. Okay, on this one I might use the calculator because I can. And it was telling me the equation was 96. Oh, this one. Okay, this one I did on purpose. 3/4. Notice I did. This is the first time we've seen one where it didn't say. We keep having n minus 1, n minus 1, n minus 1 way up there, n minus 1 right here. Notice on this one it's just n. So my very first term, this was raised to the nth power, raised to x here. My very first term is not going to be 96. Okay, when I plug in 1, it's going to be 3/4 of 96. So when I go look at my table, the very first term, notice, is not 96, it's 72. Okay, so you can tell me this one is 72 is the first term, 54 is the second one. I like to write these as fractions. This is 81 over 2. This is 243 over 8. And there we go. Okay, come back for the next video.